In this example, we're going to look at the graphical properties of inverse functions. We're shown the function g in figure 1, and we're going to look at graphing its inverse. So the key property that we want to know is that if the point AB is on the graph of y equals, in this case, g of x, then when we look at the inverse, the x and y pairs are going to essentially switch roles. So that would mean that the point B comma A is on the graph of g inverse. So that'll be on the graph of y equals g inverse of x. All right, so as we look at this graph, we see, let's start on the end, we see the point 5, 2 on g. So when we look to graph the inverse, we're going to see the point 2, 5. So we'll plot 2, 5 in there. Similarly, we see the point 2, 1 on the graph of g. So for g inverse, we'll have the point 1, 2. And then continuing, we see the point 1, 0 on g. So we'll have 0, 1 on g inverse. And then the second piece, this little piecewise function, the second piece looks linear. So we can see we've got our first half of it here, and I'll connect that. Here's our first half. And then we'll look at this linear piece. So I'm going to just grab the endpoint. -5, -3 is on g. So -3, -5 will be on that inverse. And I know that piece is linear, so I'm just going to connect it then through there. All right. So we can see in this graph that this graph of y equals g of x is reflected across the graph of y equals x to give us that inverse. And I'll label that. So there's y equals g inverse of x. So the last thing we're going to do is state the domain and range of g and g inverse. And we can do this on the graph, but there's also a key property that we want to keep in mind. So the domain of g is going to be the same as the range of g inverse. And that's coming from the fact that we switch all of those xy pairs when looking at the inverse. Similarly, the range of g is the same as the domain of g inverse. All right, so we'll state each of these. And for g, we'll see that the domain, and I'll put each of these in interval notation, goes from -3 to 2 and includes each of those n values. So I'll put a square bracket with -3, 2 and another square bracket. And the range for this function goes the domain of g, as we can see on the graph, is -5 to 5, and it's including that endpoint -5 and 5. So we'll list this one as -5 to 5 with square brackets on each end there, since we see those filled in circles. And then our range for g, we go from -3 to 2, and again, each of those ends are included. Now, when we look at the domain of g inverse, we can see it goes from -3 to 2, which matches what we just talked about. That's exactly the same as our range of g. And our range of g inverse, not surprisingly, goes from -5 to 5, which is again the same as the domain of g. And those are the same.